And welcome back to the live session. So today we are going to solve a very interesting problem. LeetCode 3212 count submatrix with equal frequency of x and y. So this problem is really good because it combines 2D matrix travel, prefix sum concept and a bit of smart observation to optimize the solution. It might look a brute force problem where we try all possible submatrix, but that would be too slow. So in this session we will learn how to optimize it using an efficient approach. So we will go step by step. First understand the problem clearly, then look at the brute force idea, optimize it using prefix sum, and finally implement the solution as C++. So we will also discuss the time and space complexity, which is very important for interviews. So stay tuned, think along with me, and feel free to drop your ideas and doubt in the chat. So let's get started. So in today's video, we are going to solve a LeetCode problem 3212 count submatrix with the equal frequency of x and y. So what is the question? We are given an 2D grid containing. So what is the question? We are given an 2D grid containing characters x and y. Then we need to count the number of submatrix such that the number of x should be equal to number of y, and there should be at least one x inside the submatrix. So that's our question. So how we are going to solve? So the key idea is we are going to use a prefix sum plus row wise accumulation technique. So which technique we are going to use? Prefix sum plus row wise accumulation technique. So why we are using this method? Because if we try the brute force approach and we try the all the submatrix, it's take O of n square, sorry n power 4, that should be too slow. Instead, we are going to compare the rows and maintain the cumulative counts and convert that manageable using prefix accumulation. So what is the concept of this problem is, for the every problem j, we will maintain sum x, one variable sum x of j. It should be total x from row 0 to row 1. So that sum x will be stores the total x's from row 0 to I. And we will declare another variable, that is sum y, and sum y of j will stores total y's from our row 0 to I. Then at each cell we will check if our sum x of j is equal to sum y of j, and sum x of j should be greater than 0. So that means a valid submatrix exists ending at I comma j. So don't worry, we will go through this all. So we are just going through the concept only. So we are going to use prefix sum row wise accumulation technique we are going to use. So why we are using this method? If we use the brute force and try all the submatrix, it will take big O of n power 4. That should be too slow. Instead, what we are going to do, we are just going to compare the row and maintain cumulative counts. And we will convert our 2D problem to manageable using prefix accumulation. So first, we have a function int number of matrix and we have one character vector grid. So first what we are going to do, first we will take the row length, how many rows it has. So this is one row, right? So this is one row and this is one row. So first we are going to take the length of our given row, that should be grid dot size, and we want column length also, right? So column equal to grid of first element dot size. So it will give the column length and this row will give the row length, this will give the column length. So we are getting the how many number of rows and how many columns are there, we are just taking. Next, I am going to create two vector. As I said before, we will have sum x and sum y. So vector int and then sum x. Sum x will have column length which will be filled by 0. So why we are giving here columns comma 0? So how many length we get in this columns? So that much length we will have the default value as 0. So default value as 0. So we are giving a 0. Then I am creating another vector int sum y in the same length columns comma 0. So why are we getting this array? So this array stores here our sums of x's, right? So it will stores the cumulative count of x in the column j. So this sum x will store the count of x's in the column. This sum y will count the y in our column. So basically this is our row and this is each column. So this is one column, this is one column, and this is one column. So my sum x will count each column x and each column y. So sum x will count the x and sum y will count the y. So why we are getting this? Because we want to track count vertically. That means from the top to the current row. So we want to track the count vertically. We are getting this arrays. Understood? Then in result equal to 0, why I am going to write result, we are going to return to our function because they have asked the return type in int, right? So we are going to return this result to store the final answer, the number of valid matrix, and we are going to return this. Then I am writing one for loop. So int I equal to 0, my I should be less than rows and then I plus plus. So this loop will traverse each row. So this loop will traverse the each row, and inside this I am going to write int x equal to 0 and then y equal to 0. So why I am taking this? To temporarily count in the current row. The temporary counters for the current row, we are taking this x and y. So this x means the count of the x in the current row. That means from the column 0 to column j. So for column 0 to column j. So this y represents the count of y in the current row. So this x will take the count of x in the current row. This y will take the count of current y in current row. So why we are taking this? We build the prefix sum for each row. So inside this, I am going to write another for loop. So this first for loop is for row, this for loop is for row, and this for loop is for, and this for loop is for column. So column, then j plus plus. So the first for loop is to traverse the row, the second loop is to traverse the column. So inside this, what I am going to write? So we are going to write one condition. If my grid of I of j is equals to the character x, then what we are going to do? We are going to update our x. That means we are going to update the count. If one x is present, then x will be 1. If 2 or 3 x is present, the count will be 2 or 3. So every time if our element is x, then the x will be incremented. Else if my grid of I of j is equal to character y, then what we are going to do? We are going to increment my y count. So this will increment the y count. So it will update the row prefix count. So this will update the row prefix count. So what does that means? So up to column j, how many x and y we saw in this row, it will increment. So how many x and y we saw in our row, that much time Then what we will do? So inside some x and some y, right? So now we are going to update. So next, my sum x of j plus or equal to my x, and my sum y of j plus or equal to my y count. So we are adding the row contribution to the column prefix. So now the sum of x of j is equal to total number of x from 0 row to I. So it will add the total x from row 0 to my I, and the column 0 to my j. So this will add the total x in our grade, that row starting from 0 to I and the column that starting from 0 to j. So how many x we saw in our grade, that much count it will now add to the sum x of j. So this sum y of j will have the total y that from row 0 to my I and columns 0 to j. So this will shows the y count, row starting from 0 to I and column starting from 0 to j. So this is like a building a 2D prefix sum, right? So this is like building a 2D prefix sum. So next what we are going to do? Next we are going to check one condition. If my sum x of j is greater than 0 and my sum x of j is equal to sum y of j. So here it should be capital Y because we named it in capital. Then what we are going to do? We are just going to increment our result. So what condition it will check? If the equal number of x and y are there, then we will count. So if our x count is greater than 0, then what is our question says here? If at least one x present, increment. An equal frequency of x and y, then also increment. So here what we have, the written condition is if my x at least 1 present also, increment the result count, or if the both the value are true, then incrementing the count. If true, we will found the valid submatrix ending at I comma j. So if this condition is true, we will found the valid submatrix ending at I comma j. So at finally what we are going to return? At finally we are going to return our result, right? So at finally we are going to return our result. So what we are going to here? So first we are taking the row and column size, then we are declare to array. This sum x will store the x count and the sum y will store the count of y. Then we are declaring one variable result equal to 0 to store the final result, how many submatrix we have, the count. Then we return one for loop for the traverse of row. Then this x and y will count how many x we saw in our row and column. This count the x value and this count the y value. Then inside that we have written one for loop to traverse the column, and inside this what we are writing, if any element is equal to my x character, increment the x count. Else if my character is y, then increment the y count. Then what we are going to do? We are just adding the x value to my sum x and y value to the sum y, the total value. Then we are checking if my if my array is contain at least one x value, if my grid is contain at least one x, then increment the result. Or if my grid is contain same count of x and y, then also increment my result. So if you see one example, I'm having my grid. So here I'm having my grid that is equal to, that is 2D array, right? So inside that I am writing x comma y. Then another grid I am writing here y and then x. So this is my grid. This is my sample grid. So what is our goal? Count submatrix where number of x equal to number of y and at least one x exists, right? So in the initial stage, what I am having, my sum x is equal to 0. Initially at the stage of my sum x is equal to 0 comma 0, right? And my sum y will be initially equal to it is also 0 comma 0. Then what my result? In the initial it is also in the 0 state. So for the iteration 1, first the I will be equal to 0. The I will be equal to 0 and my x and y count will be also 0. So the x will be equal to 0, y count also will be 0. And next it will come, so the I is equal to 0, x and y will be initialized at 0. Now my j should be equal to 0. My I will be equal to 0, my j will be equal to 0. So first it will check for cell x. So first it will check for cell S. So now what will happen? The first element in the grid is x. So 0 comma 0, the element row is 0, j is 0, column is 0, row is 0. So what element I am having here? That is x. Then now the x count will be incremented to 1, right? So my x count will be equal to 1. And if condition is passed, then it will come to this sum of j plus or equal to x. So what it will happen? My sum x of what is my j value? My j value is 0. My j value is now 0. So sum of 0 should be equal to 0 plus 1. Now in my sum x of 0, my count will be 1. Then in my sum of y, what I am having? I am having nothing because I don't have y in my 0 comma 0. So this will be remains same. So this will be remain same. So it will check this condition. So this will check the condition if the sum of x j, that means sum of x count is greater than 0. Yeah, x count is greater than 0 or sum x is equal to 1. But here we are using and, right? So both the condition should be same. Both the condition should be true. So this condition also should be true. This condition also should be true. So this condition has become true because we have sum x count as 1. But what is our sum x count? Our sum x count is 1. What is my sum y count? That is 0. So 1 is not equal to 0. So result will not be incremented. So again what will happen? Now this will end terminated and my j loop will be incremented to 1. So when the j loop will be incremented to 1, it will move on to this cell, right? So if you see the indexes, it is 0 row and this is 0 column, 1 column. So this is 0th row and this is 1th row. So what I am having 0th row 1th column, I am having y. So now the y will 1. So the y count will be 1 because here we have y, right? So the y will be now 1. So now what we have? The sum x is same count because here we are using this for loop only. Where the compiler is in now this for loop. So the x count is 1, the y count is 1. So now here 0 plus 1, I am having my sum x now equal to 1. Then what it will check? It will check for this condition. So what is my sum x value here? My sum x value is 1. So 1 greater than 0, yeah, the condition gets true. So here it will check 1 greater than 0, the condition is true. Now here it will be true. And what? My sum of x. What I am having my sum of x? My sum of x is 1. So 1 equal to what is my sum y value? 1. So that means this is also true. So true and true, it is true. So now my result will be equal to 1. So my result will be equal to 1. So now the first iteration is completed. Now it will move on to the row for loop. Now my I will be incremented to 1. That means now we are in the second iteration. My I will be incremented to 1. So again what will happen? It will again initialize the new value of x and y that will be start from 0. So all the value will be start from 0. So sum x and sum y will be same because we initialize the sum x and sum y in the outer of the loop. So it will not create every time when the iteration begin. So now the final value of sum x is 1 and my sum y is, it is also 1. So my j is now again it will start from 0. So my I is 1, j is 0. What I am having in a 0th row? Sorry, 1th row, 0th column, that is y. So first what will happen? My y count will be incremented to 1 because the first character is y, right? So y will be incremented to 1. So now what will happen? There is no x, y will be now incremented to 1. Then 1 plus, what is my y count? That is 1. So now sum y what I am having? Sum y I am having 2. So here it is the 0 and plus 1, it should be equal to 1 because here we are checking j. So here it is in the, okay. So for the y cell, first what we are having? First we are having the sum of 0 value is 0 and now the y value is now equal to 1. So this is the new column value and this is our y count value. So this is also equal to 1 and here it's still same, that is equal to 1. So now again if we check, our x count is, what I am having my x count? I am having 1. So that is also greater than 0 and it will check my sum of x of j. What I am having here? That is 1. So 1 equal to 1, that is also become true. Then my result will be now incremented to 2. So now the result will be incremented to 2. Now what will happen? My j will be incremented to 1. Sorry, my j will be incremented to 1. So what will happen? It will check for the x cell. So here I am having one row, one column, what I am having x. So now the x count will be 1 and my y count will be 0. So already I am having sum x of 1, what I am having 1. Then now x value 1 plus 1 now equal to 2. So I am having Sum y of 1 I am already having 1. Then 1 plus 1 now it will become 2. So now it will check here. What I am having my sum x? 2. Right? So 2 greater than 2, the condition is true. Now here 2 equal to 2, this condition also true. Now the result will be incremented. Now it is equal to 3. So the final answer will be 3. So what are the submatrix or counter? These are prefix submatrix from the top left. So top row till column 1, first row till row 1, then the full grade. So now we will run this code. So see, we have got the correct answer and each test case have passed. We try to submit this. So our solution is passed. We have done in the optimized way. So if you see, the time complexity of this problem is, so the time complexity is big O of, we used for loop. So one for loop is for row and another for loop is for column. So the time complexity will be row into column. So why? So the outer loop runs. So this loop will be run for row times and this loop will be run for column times. So the total operation will be row into column. So our time complexity is big O of row into column. Then our space complexity is big O of columns. So why? We are using two vectors. So two array of size column. So in our column size we are using two vectors. So the time complexity is, so for one vector it is big O of columns. Then for another vector it is big O of columns. So if we add that, we will get big O of columns. So our time complexity is big O of row into column. Our space complexity is big O of columns. So the other variable we have used like result xy will have the constant space. So we will ignore that. So the space complexity will be 0 of columns. So I hope you understood this problem. So if you have any doubt, let me see in the chats. So thank you for listening. So if you like this video, please share and subscribe. So thank you for watching. So if you want more LeetCode problems, we have a playlist. The link is provided in the description below. Please check out. Thank you.